Hey everyone, good morning, good afternoon. Welcome to our webinar on how to predictably migrate legacy MPP databases such as Netezza Teradata to Amazon Redshift, a very topical subject given that Netezza is past end of service. We see many clients are facing challenges in finding the migration pathway with least resistance. More on that later today. I'll do a quick round of introductions of the speakers. I'm very excited to co-present this webinar along with Vinay Shukla, who is the Principal Product Manager for Amazon Redshift, and we also have our in-house expert, Jay Palaniappan, who is our Principal Solutions Architect. Couple of housekeeping activities. You have an option on your screen to pop in your questions. I see that many of you have already done so. Towards the end of the webinar, we would sort through them, find common ones, and try answering as many questions as possible. Nevertheless, if we don't get all of them answered, we will send an email with all the details. We would also email link to the recorded webinar, so you can watch it at your leisure or share it with friends. I'll now give a quick introduction about Agilisium, and I'll then set the agenda and move forward. We are a big data and analytics company focusing on the cloud. Our DNA is to help organizations take their data to insights leap. We are over 350 plus employees. We started in 2013. We've been growing from strength to strength. We have over 60 people in the US spread across LA, where we are headquartered, Chicago, and Texas. And we have strategic global presence across India, Canada, Costa Rica, Netherlands, and UK. The global delivery center is over 250 in India and minor presence in the rest of the locations. And in terms of accreditations, our focus has always been on data and analytics. The first competency that we got from AWS was on data and analytics, followed by service delivery partner status for Amazon Redshift, EMR, and QuickSight. And we are also premier consulting partners with other technology platforms that work really well with AWS, like Databricks and SnapLogic. We have got listed 3 years in a row now in INC's 5,000 fastest growing US private companies, a testimony to how fast we have been growing and how stable our business is. A quick view about our marquee clients. You would see these are heavily concentrated on 2 industry verticals. The first one being media and entertainment, which also includes gaming. So pretty much Disney is the only studio that we have not worked with. You would see we have worked with Universal Music Group, 21st Century Fox, Comcast, NBC, and Warner Brothers. All of these are enterprise big data analytics solutions that we have delivered for them. On the life sciences side, we have done some great work for Amgen across the globe, and also for quantum health and venture capital firm like Intuitive Surgical. We also worked with clients from other industry verticals, especially the manufacturing and high tech, like Reliance, Cadence, and Juniper Network, and we also done some work for the Fed government. With that said, let me give a quick overview about our migration experience. All in all, we have over 180 plus person years in migrating enterprise data lakes and enterprise data warehouses. We have done over 250 enterprise data warehouse migrations, which translated to over 15 plus petabytes. And we have a huge pool of certified cloud and big data experts, which right now is around 85. And with respect to MPP experience, we have done over 100 plus legacy MPP migrations, over 180 assessments for migrations, and we have a very strong pipeline in terms of large-scale Netezza Teradata migration opportunities. AWS has taken notice of it. We are one of the preferred partners under the AWS Database Freedom Incentive Program, where clients are offered huge cost benefits. Agilisium, as an advanced consulting partner, facilitates these cost benefits for both large-scale migrations as well as something like a proof of concept. And many of these migrations are driven by former Teradata and Netezza subject matter experts, and the source systems for which we help devise migration pathways are across IBM, Teradata, and other MPPs like Greenplum, Vertica, and Exadata. IBM pretty much TwinFin, Mako, and Pure Data. Teradata is the 2,700 class appliances, and also the enterprise grade 6,000 class appliances, and also the latest one like Vantage and Aster. With that said, I'll quickly set the agenda. Vinay Shukla would be talking about the challenges today with legacy MPP databases and why Amazon Redshift is the right fit cloud, followed by Jay talking on the topic of the day, how to predictably migrate legacy MPP databases to Amazon Redshift. Over to you, Vinay.
Hello, everyone. My name is Vinay Shukla. I'm a principal product manager with the AWS, working on Amazon Redshift. And today, I was going to talk about Amazon Redshift, why a lot of customers are migrating to Amazon Redshift from legacy data warehouses, and also give you a preview of new features of Amazon Redshift that have been launched over the last year or so. So diving into the topic, what are the reasons why customers have tried to move away from legacy data warehouses? And as a matter of fact, we have tens of thousands of customers who are running on Amazon Redshift already, and many of them have migrated from legacy data warehouses. Well, some of the reasons are legacy data warehouses are typically installed on-prem, where the hardware may have reached peak capacity. Onboarding new workloads and more users is challenging, and that challenge reflects in customers perhaps missing their SLAs or their reports and data ingestion or ETL jobs taking longer and longer as they onboard more and more data. And this flies in the face of corporate mandate to democratize access to data. So that means more analysts and data scientists want access to the data, versus the system might not have enough capacity to handle the increased workload. And oftentimes in on-prem data warehouses, new sources of data like clickstream, etc., are not there. So that leads to not having a 360 visibility of the entire business. And often it leads to data silos and increases cost. So for these drivers, customers move to Amazon Redshift so they can avoid many of those pitfalls. And as a matter of fact, Amazon Redshift is now the most popular cloud data warehouse, and tens of thousands of customers use it today. It's also the fastest cloud data warehouse. It is also the most cost-effective cloud data warehouse, and especially with the RI discounts that Redshift offers, customers can spend very little and still get a very effective, cost-effective solution. And Redshift is the first cloud data warehouse that started integrating with querying data directly from the data lake, and now we have exabytes of data customers are querying with Amazon Redshift. So let's look at what are the new features of Amazon Redshift. So over the past years, many of these features were launched, and I will get into details on some of the top features. So let's dive into some of them. Concurrency scaling was a new feature of Amazon Redshift that was launched earlier this year in March. And with this feature, Redshift scales for your peak demand. So you can provision your cluster just for the average demand, and when the peaks of activity arrives, Redshift will make additional clusters capacity available in seconds to serve those needs. So how does this work? As an analogy, imagine going to a popular movie the day it came out Friday, and there is a huge queue forming up. What if additional ticket windows open to drain that queue? Well, in effect, that's what happens here, is when a queue starts to form, Redshift will spin up additional clusters in seconds and will allow new queries to be routed to those transparently to the user, so the customer will see no difference in throughput even as the number of users keep increasing. And more importantly, this feature is free for 97% of the customer, and the reason it is free for 97% of the customers is because every 24 hours the main cluster is running. We issue a 1-hour credit to use additional concurrency scaling clusters. And with that credit, we have found across our fleet, customers need this capability for less than an hour a day, and that's why this feature becomes free for them. The additional hardware capacity and additional cluster becomes free for them. So with this feature, enabling this feature is very simple. Customers can configure this feature at a per queue basis. So for example, in this screenshot you see at Q1, I'm indicating that concurrency scaling is enabled by automatic mode, and I can have up to 10 clusters where this feature, the feature can engage if needed. Another great benefit of this feature is evident on this slide. You can see on the x-axis the number of users that are concurrently active, and you can see the number of users increasing left to right. And also on the y-axis you see the throughput, which is query per hour, and you can see even in the face of more and more users coming, the throughput does not decrease, it increases linearly. So with this, Redshift shows that even in the face of increasing number of users, Redshift scales virtually to serve unlimited number of users. Another feature of Redshift is elastic resize, and elastic resize can grow or shrink the size of your cluster in minutes. And the use case for this is, imagine, and actually this is a real example from one of our customers that gets a very big ETL job every Wednesday afternoon. And for the Wednesday afternoon, when they process that ETL job, they double the size of their cluster. And after the ETL job is, that complex ETL job is done, they reduce the size to their normal cluster size. And they do that, increase that size and reduce the size in minutes with this feature. So with this feature, Redshift, you can add or remove capacity from your cluster in minutes. Another big area of focus for Redshift has been on automating a lot of the maintenance and tuning tasks so that Redshift becomes even easier to use. So Redshift has automated the analyze and the vacuum earlier this year, and very recently we also automated setting the right concurrency slot for your workload manager. So all that is automatic, and Redshift is making more and more progress that I will show you on the next screen to make Redshift fully automatic. Our goal is zero maintenance and zero tuning. So in auto vacuum, Redshift released this feature earlier this year. Redshift, as you delete data from your tables, it might create holes in those tables, and that Redshift with vacuum will reclaim this space by automatically compacting data, and this not only leads to lower storage usage, but also increases the performance. So this is now automatic, and you can benefit from this feature without having to do anything. Another big ease of use feature Redshift implemented was to support stored procedure, and this makes migration to Redshift even easier. So Redshift supports stored procedure in PLPG SQL, so you can bring your familiar SQL logic to the stored procedure, and you can bring your stored procedures that have been developed over the years as you are migrating from legacy data warehouses. And even better, Redshift supports conversion of stored procedure from various legacy data warehouses using the AWS Schema conversion tool. So you can convert them very easily, and I will show you a slide on that next. So in summary, Redshift has become much easier to use. It automates most of the maintenance and tuning job. One thing I would like to mention is that Redshift is also automating data distribution. So as you create a table, Redshift, and you can set this style as auto, and Redshift will automatically figure out what is the appropriate data distribution style, so you don't have to do anything there. Redshift released a new query editor. So the use case there is for admins who quickly want to run queries without having to install or set up another JDBC client. They can directly run queries and visualize the result from their AWS console. A unique feature of Redshift is its ability to query data lake. So this ability comes in handy for 3 different use cases. One use case number 1 is the data was never ingested in Redshift. If you're keeping your golden copy of data and the bronze copy of data might be in your data lake, and Redshift still gives you the ability to query that copy of data without having to ingest that data into Redshift. A second use case for this feature is customers want to share some data that has been processed from their Redshift cluster with other AWS analytics. For example, you may want to share some data with your data scientists that are using Athena or are using SageMaker, and you can unload that data from Redshift and still retain the ability to query that data through Redshift Spectrum. So this data sharing use case also is possible with Redshift Spectrum. And the third reason a lot of customers use Redshift Spectrum is that it allows them to keep the size of the data in the Redshift cluster limited while they store a lot of more data, like colder data, in S3 with Redshift Spectrum. And this also allows customers to have a single copy of data in S3, and they can point multiple Redshift clusters to that single copy of data so that they can scale their compute independently in separate clusters. So with Redshift Spectrum, a big feature we are releasing now, it's available in preview, is exporting data out of Redshift for data lake use cases. And Redshift now supports unloading that data in Parquet format. So Redshift supports various formats for ingestion of data: Parquet, ORC, Arrow, JSON. And now when it exports data, it also supports Parquet in addition to JSON and CSV that it supported before. Another enhancement in Redshift Spectrum was its integration with lake formation, and this integration allows Redshift Spectrum to be able to enforce column-level access control on the table, its external tables it's querying. So with Redshift Spectrum, as I mentioned on the previous slide, you can query a table, and the data for that table may reside in S3, and depending on who the user is, certain users will be able to see the certain columns on that table as specified by the security policy that a security admin can use lake formation to define. So column level access control is available through AWS lake formation integration, and Redshift Spectrum works with that. So all these security features have been are part of Redshift. Redshift provides security built in without any extra cost. It provides end-to-end encryption. It also supports AWS IAM integration, and all the encryption keys are stored in the AWS key management system. Redshift also comes with lots of compliance, and all these compliance are part of built-in security without any extra cost. And on Amazon Redshift website, you can see a host of certification that Redshift has. So as I mentioned, Redshift supports integration with Schema conversion tool, and with this feature, you can bring your legacy data warehouses and convert the schema objects such as tables and views, move some data from your source to the target of Redshift database, and also convert your stored procedures. So this reduces the effort you have to spend to migrate over. With this, I wanted to summarize Redshift. It's the most popular cloud data warehouses. We have tens of thousands of customers that use it. It's also the fastest cloud data warehouse and the most cost-effective data warehouse. And the data warehouse also allows you to query data lake directly. So a lot of customers are taking advantage of Redshift Spectrum to query data in data lake, and it becomes what's called a lake house architecture where you're using both a data warehouse as well as a data lake together, and you're storing your colder data in the data lake and still retain the ability to query that data, and especially use it for clickstream analytics and combine it with your data warehouse. So this is a short summary of Amazon Redshift, and with this I will pass it back to AWS partner Agilisium. Thank you.
Thank you, Vinay. This is Jay Palaniappan. I'm a Principal Solutions Architect with Agilisium. So Vinay already made a compelling case, right, on why Redshift and the AWS ecosystem of services is good for modernizing your data warehouse, right? It's a compelling the capabilities of the services. So we want to now talk about so why most of our customers that we work with want to move away from their existing legacy data warehouses into a more modern one, right? Potentially a cloud-based one. So the first and foremost reason is data platform modernization, right? Most of our customers are seeing an explosive data growth, right? And their traditional data warehouse platforms cannot scale effectively to keep up with the data growth. So they need something that can scale effectively, that can help the customer fit the business needs, right? And the other reasons that you all have encountered is more and more customers want the data to be, given to them faster. That means real-time requirements, and they want to bolt on data science toolkits on top of it, where the legacy tool systems does not provide that capability to you, right? So the other is cloud transformation. Like a lot of organizations are going through that phase. So that means like you as a data team are kind of forced to move along with it, right? Whether you want it or not. So those times, some of the existing platforms cannot be moved into the platform of choice. For example, Netezza to AWS, right? So that you're mandated by the cloud transformation initiative, where you are asked to move into cloud. And the other popular reasons, again, like as part of the cloud transformation, is also like operational efficiency and cost management. So you want to move away from an CapEx model where spending really large sum of money over a period of time into more a subscription-based model, right? That can allow you to spread your risk better over the number of years. So that's another reason. And choice of services as well. Like if you're on-prem, stuck with your legacy data warehouses, you do not have a lot of tools. If you want to get a new tool or a service or a platform, it takes years to get it, right? For example, I want to run something on Hadoop, so it's kind of almost impossible for you to set up a Hadoop-based ecosystem in your platform if there is no organizational mandate or a big requirement attached to it. But it is trivial on cloud. If I want to experiment with the Hadoop, how can I do that? You can spin up EMR or Glue and can make that happen. Last but not least, can end up support and licensing reasons, where your product or service is going out of service. Your platform provider doesn't want to support it anymore, or draconian licensing costs. We heard a lot of it, right? So from the very well-known database providers. So these are real reasons why our customers want to migrate away from their legacy ecosystems to more cloud-based ones. So as you can see, when you look at these reasons, Redshift fits in only or solves only part of the puzzle. However, if you look at the entire AWS ecosystem as a whole, it allows you to innovate. It allows you to take care of your existing use cases and then some, right? So it is important for you to look the AWS ecosystem holistically on top of your Redshift use cases when you're looking at modernizing your platforms. So the next topic is, yes, I want to modernize it. How do I go about it? Where do I start? So it is easier said than done, right? So first and foremost, you need to take a stock of your ecosystem. So more often than not, when we engage with our customer, we realize that the knowledge of your data ecosystem is kind of spread out, right? Not one person or one knowledge base has all this information. So you need to go and talk to the experts, talk to the owners of different pieces of this platform to get an understanding of what is going on in your data platform and how do you get from point A to point B, right? So that starts with understanding your data. Where are my data? How much data do I have? What's the data growth, right? And life cycle and so forth. And then the type of instances, clusters, and databases that you have. to the number of ETL processes and the toolkits around it. What are the tools that you guys are using to process your ETL? Is it, your typical Informatica talent, or do you guys purchase a third-party connector to bring in Salesforce data, things like that? So you need to have a good understanding of your ETL ecosystem. Your security and governance is an important aspect as well. You want to make sure that whatever support you guys were providing earlier, it still needs to be provided. But then if you are doing data science on top of it, you are doing real-time analytics on top of it, how am I going to make that data available to my customers as well? Do you have to have a good understanding of that as well? Downstream systems, right? Your BI, insights, and ad hoc querying, data science workloads. You may even have data as a service where you're providing microservices-based architecture, or like a MuleSoft kind of an integration platform to provide data to your downstream systems. You need to have a good understanding of how those integrations work. These are business use cases, or functional use cases, right? On top of that, you will have definitely operational requirements, like how am I going to meet the SLA to meet the business needs, right? How am I going to manage my backup and DR in this new ecosystem? How am I going to monitor this? Can my existing monitoring service support here, or will I have to adopt the cloud's own monitoring services? And so these are important things that you have to make sure that you have a good understanding of, and take the requirements and ensure that it's captured. Right? Last but not least, DevOps, right? Your legacy ecosystem, not sure how old it is, could be as recent as few years, as old as several years, right? DevOps concept may not exist in your old ecosystem, but when you're coming into cloud, it is really, really important that you follow the DevOps methodology, even for your data platform, data ecosystems, because it's important to be agile and to nimble and provide value to your end users faster. So now, assume that you got there. I got my requirements. I did my initial assessment of what's out there, what my need is. Now we need to go from plan A, where you are, to where you want to be, right? So, and you start with that with sort of what we call it as a cloud fit assessment. So you take your requirements and try to map it out to a cloud-based service that can provide or support the need. For example, I need to support my existing ETL pipelines that is running on top of Informatica, so probably I'll start with, Redshift there, right? But I also want to support data science. So that means I want to bring in SageMaker. So you just start to fit your need with the tools available and ensure that there is a fitment, right? So more often than not, AWS is going to provide all the services that you need, but just you have to go through a conscious process of doing that mapping, right? You've done the fitment test, and then you validated that the cloud provider provides you all the tools at a high level that you think needed for doing this migration. Then comes the migration assessment, right? This is the most important piece, where you deep dive into your requirements and start mapping out how this migration will actually happen. Do I have to, expire or archive some of my data, or do I have to bring all my data and tier them, right? How each of these services will be used, what my re-architected framework will look like, what my TCO and timeline would look like for this migration. So that is part of the migration assessment that you will have a very good understanding of where the final stage is, right? So that will lead you to the one of three paths that we see usually, which is either you do a full-scale migration where my requirements are straightforward, my systems are fully contained, I have a good idea of where it is, I can do this full migration within a period of timeline that you think is the right fit for your business needs, right? Or we have more large complex implementation. We have seen a phased migration where people take more problematic requirements, or requirements that is sort of the edge cases that cause your systems to peak a lot, right? They move those requirements into cloud and build a system around it, and gradually move the rest of the workloads in there, and finally complete their full migration. That may involve again, additional use cases to support your real-time needs, your data science needs, and so forth. We also seen in certain cases where people decided, depending on, again, upon your source systems, whether they're supported in your cloud platforms or not, this may take more time. It may not fit into our schedule. There are time constraints. There's a cost constraint. So I want to move my existing system assets. We have seen that happening as well. So people move into cloud assets and then try to re-platform, rethink their strategy. So again, this is the usual sort of path that we see customer taking, and we have helped our customers a lot during this journey. So I just want to talk about our process now. This is how generally you would approach a migration. So, and we're going to talk about how to make this predictable, right? So we have helped ton of customers. We have a lot of experience collectively in working with multiple projects, and during this process, we have built a set of toolkits, set of accelerators to make sure that these assessments are done thoroughly, right? And the migration is done as fast as you can using toolkits, either available through the cloud provider, third party, or our own inbuilt tools, right? So these are the ones that help us, perform that predictable migration for you. So I'm going to quickly talk about some of these toolkits in the next slide, so you'll have a kind of a decent understanding of what those toolkits are, right? But I just want to make sure that our experience and these toolkits is what can definitely help you make that migration pathway more predictable and more effective. So some of the platforms or toolkits that we are going to talk about here are available on our cloud provider as well, and we have enhanced it or complemented with our own because of the difference in source systems. First and foremost, we have a very detailed discovery questionnaire. We talked about a couple of slides ago, right? You need to take a stock of what your existing platform is. And it changes, again, the kind of questions, the kind of data that you have changes between your source system. So we have a very detailed discovery questionnaire depending upon your source system to understand what you have in there, right? And we have database parsers that can go into your source system and look at your tables, views, internal, SQL, PL SQL, or functions or SPs that you've written, or external code that you've written using VTEX scripts or your Python scripts or any other thing for that matter, right? So we go in there, we kind of parse through that, your existing code and your existing ecosystem, and figure out what are the dependencies in there, what needs to actually happen, where are the relationship in there. We need to make sure that we capture every single requirement out there that's not being surfaced, right, through your general documentation and so forth. On top of that, we have historical, script to copy the historical data, and DDL converters. I know Amazon provides out-of-the-box SCT converters. It's good for certain use cases, not as mature in certain others. So we complement that, and we ensure that the DDL conversion and historical data migration is as easy as possible. On top of that, we have our own metadata-based ETL frameworks, data deduplicator and automation frameworks that can accelerate the migration effort as well. So I think this kind of gives you an idea of what are our value add, right? So in terms of performing the migration and performing the assessment. So with that, I'm just going to hand this over to Arun. He's going to talk a little bit more about the importance of doing this assessment properly and making sure that you are utilizing these toolkits and our accelerators to ensure that there's a predictable migration. So thank you. Arun.
Thank you. Yeah, thank you, Jay. Migration of legacy MPP databases such as Teradata, Netezza, Vertica to the cloud is a complex process. Enterprises typically invest millions of dollars in such engagements for infrastructure, consulting services, and implementation. Yet Gartner states 83% of such data migration projects either fail outright or exceed their budgets and schedules. Based on our past experience where clients have called in to fix an existing in-flight migration projects, we have seen that many of these enterprises invested poorly on assessment and planning phase, and eventually they set themselves up for failure. So with that said, I want to quickly present our assessment offerings, which, as Jay explained during the migration pathways, helps you to bring in the predictability and certainty into your decision cycle. We have two assessments. The first assessment is about AWS Fit Assessment, which typically runs anywhere between 4 to 6 weeks. The cost here is mentioned around $25K to $40K. Most of these scenarios, these is effectively offered at $0 or at a very low cost, depending on where you are in your journey with AWS. We typically jointly fund these assessments along with AWS as a consulting partner, advanced consulting partner. For this fit assessment, it's all about evaluating AWS as a platform to meet your needs with respect to performance uplift, cost efficiency, and fitment for your innovative requirements. So we do this in two aspects. We address this in two aspects. The first one is identify use cases with respect to your innovative requirements, which could be serverless, data democratization, making data accessible to your data scientists so you can innovate faster. So many of that is being addressed through a quick-fire POCs. While the other two aspects on what is the potential uplift that you would gain in terms of performance and cost efficiency, that is ascertained through a series of benchmark tests. We have our own list of benchmark tests, not limited to baseline, concurrency, availability, so on and so forth. And these are being performed against a candidate set of workloads across your ETL, BI, data science, and interactive query workloads. So once we are done with these benchmark test and also the quick fire POCs, we'll be in a very good position to tell you, hey, AWS is the platform to go because we have solid data points to say this is the right platform for your migration requirements and your innovative data modernization requirements. And we prove that through reports such as performance benchmarking reports and our cost projections based on the benchmark test that we did, where the combination of different test was run against different server instances, Redshift instances, scalable compute model, and we'll also be able to arrive at a future state architecture on AWS based on your innovative requirements. So this is the first fit assessment offering that we would like to present today. The second one is about migration assessment. The first assessment addressed the question on if AWS is the right platform for me. What other services within AWS would be required to address my innovation requirements? The second assessment is all about, now we have decided that AWS is the way to go. How long would it take to migrate your workloads, and what would it cost you in terms of resources and infrastructure, right? So that is where the migration assessment comes. This again is encapsulated within 2 to 6 weeks, depending on the complexity of the workload, and it's costed again 25 grand to 75 grand. Again, we have offered this in many of the cases at zero cost, depending on the strategic nature of the account and where the client is in their journey with respect to AWS. And we support all the instances that are mentioned in the left, right from the 2700 class appliance for Teradata, all the way through the latest Vantage and Aster offerings, and also other MPP databases like Netezza, Pure Data, Oracle Exadata, and Vertica. So we come in, we do a quick discovery, do a detailed analysis of your MPP footprint using the system tables from Teradata and other MPP databases, and we'll also help you upskill on your AWS best practices and end up with the recommendation on what is the best way forward. As Jay was mentioning, it could be either a strategic, full-scale migration, or it could be something tactical where you want to do an offloading for immediate capacity relief, something like, hey, can you offload my PySpark job to something like EMR or Glue, so that there'll be the resource contention would be greatly reduced. Or it could be something like, hey, can you do a partial migration of some of the workloads to the cloud before we can actually migrate the rest of them? So we see these as a typical approach where clients want to do a phased migration even after the assessments to ensure that they are having enough data points all along the way. So all these reports that we provide at the end of the assessment, like the current system report, data placement or rationalization study with respect to the hot, cold, warm data strategy, the future state architecture, and a fully costed migration plan. So you get a fully costed migration plan in terms of how long would it take, what would it cost in terms of infrastructure and resources at the end of this assessment. So both the assessment will reduce a lot of uncertainty in your decision-making process, and will help you decide the right services and have the right plan in place to ensure that your migration is successful. So that's the topic on predictably migrating your legacy MPP databases to the cloud. With that, we are pretty much done with the assessments. We are really good on time, and before that, before we jump onto the Q&A, I just want to let you know that if you want to learn more about these assessment offerings or anything on the presentation that we did earlier today, please feel free to drop a note to sales@agilisium.com. And if you are interested and you want to kind of quickly jump on, learn from our experts on how we can do this assessment for you, both the migration assessment or the fit assessment, please do drop a note to sales@agilisium with the subject on the type of assessment that you want to do, along with some details, some pointers on your pain points and the challenges that you have. I think that's pretty much on the content. We are good on time. Let's quickly move on to the Q&A section. So I see there's already a lot of questions. Let me quickly look at them. Okay. So Jay, let me read through the questions. It'd be great if you can address them. The first one is, does SCT convert everything DDL stored procedure code from Teradata to Redshift?
No. So Teradata to Redshift SCT does not support stored procedures, or if you are using something like BTEC scripts for your ETLs, it does not perform as of now. As you may be aware, Redshift's stored procedures capability is rather new. However, we have capabilities within our toolkit that can help you accelerate those objects out of Teradata into Redshift.
Thank you. The next question is, to use Spectrum, do you need to have a running Redshift cluster?
Yes. However, there are other ways you can run the same data and the same data model that you developed for Spectrum, because you're using AWS Glue and the data sitting on S3. You can also use tools like Athena to run your same queries. The reason where you would introduce Spectrum into the equation is you already have a Redshift cluster and you have data sitting on S3 as part of your data lake, and there are capabilities that you need to merge these two, right? Run analytics across both these tables, so to speak, at the same time. You would bring Spectrum into the equation.
Thank you. The next question is, how to plan capacity or resource when migrating from on-prem Teradata to cloud?
So the capacity planning is primarily driven by a few factors, right? One is obviously data, and your ETL and reporting needs are the two primary factors. But then, unlike your legacy systems, right, Redshift provides capabilities to run concurrent scaling, meaning you can, for your reporting needs, you can burst your read capability as you need it and then shrink back, like auto scaling, but for reporting, right? And also using elastic scaling, you can scale from 2-node Redshift cluster to a 4-node cluster in a matter of minutes. This scalability allows you to plan a little bit more just in time. I wouldn't say that you do that, because there is also cost and budgeting aspects to it, but you can scale relatively easily. You don't have to plan for peak utilization for the next 3 years when you're buying your Redshift capacity now. You see how the growth happens and then you grow accordingly. And then there are also strategies like, migrating your warm and cold data into S3, use Spectrum. There are other ways you can manage costs more effectively. So again, the most important factor is how much data you have today and what is your growth, and probably plan for a year. And if you have peak, then you plan to use concurrent scaling and so forth, and make sure that you're using your dollars wisely when you're purchasing Redshift capacity.
Awesome. The next one is on, from your prior experience, what is the typical timeline taken for a migration project?
That's a loaded question, right? So because depending upon your source system and its complexities, it takes anywhere from a few months to a few years. The highly complex project takes definitely multiple years. I wouldn't say 3 or 4 years, but at least beyond 12 months, right? However, let's say if your data warehouse is reasonably sized, when we say reasonably sized, few terabytes, we are pretty good about keeping all your ETL processes within tool sets like Informatica, and so it is a matter of few months where we can move you away from your legacy system into your new system. So it's with the automated tools and our processes, the migration path is relatively straightforward and painless for a sort of a stock ecosystem.
Awesome. Let me look through it. Yeah, this one is interesting. Can you talk about some of the most common use cases for migration from MPP databases to Amazon Redshift?
The common use cases are, I would say, data warehouses and data marts are the common use cases that we see, and we see ODS requirements coming in as well, but that the target path is a little bit more say involves multiple services, not just Redshift, because the amount of volume of data that you store is pretty large, and you have more granular data stored in an ODS, right? So again, going back to the former question, most of the time we see a proper data warehouse migration or a data mart that is solving a specific business need, right? Is what we see.
Awesome. What is the accuracy we can expect from assessment prediction, and how much efforts assessment toolkit can reduce?
Again, it depends on what your source systems are and how complex your processes is, and how thorough we are able to make that assessment, right? So assuming that we are able to capture your requirements completely through our processes, it will definitely accelerate the time by 2x, right? Easy. So we stand behind that statement.
Oh, this is an interesting one. How do you handle glob columns when migrating from Teradata to Redshift?
So blobs and clogs are not supported by Redshift as of now. So the typical way of doing that is storing your data in S3 and putting the key or the path to the blob in Redshift, and through your applications, you read from S3. It's pretty, again, relatively straightforward. AWS provides out-of-the-box toolkit. Doesn't matter what your language is, Java, Python, Node.js, whatever you're using for your reading your blob data. You can directly write into S3 and put a pointer on Redshift.
Awesome. Let's take one more question. We're pretty much good on time. Do assessment toolkits work as an extension to the output from Amazon SCT, or do they work independent of Amazon SCT?
So again, the capability of SCT is growing. We started out with our own assessment tool, which was independent of SCT because they didn't support certain source systems, but now it is becoming more comprehensive. We want to use it as much as possible because a lot of great work has happening there. We want to like piggyback on that as much as possible. But we are kind of right now, we kind of complement that, like where the source, where, for example, like, there was a great question earlier about whether SCT supports stored procedure conversions from Teradata, right? It doesn't. So our tools does. So in this case, it will be a complement to SCT there.
Awesome. I think we are right on time. We are pretty much on time. There are still more questions left. However, we'll address them through email. We'll take a pause here. We would love to thank everyone who joined us today to hear us out on how to predictably migrate legacy MPP databases like Netezza Teradata to the cloud. We hope so. We'll be doing another follow-on webinar on mostly a tech deep dive. Please let us know if you would love to hear us on that through the email. The email is sales@agilisium.com. Anything from you, Jay?
Nope, that's it from me. Thank you, everyone, for joining us and hearing us out.
Yeah, thank you, everyone. Appreciate it. Bye-bye.